This is a fantasy football analysis, an application of data input and manipulation by Riley Woods and Matt Jacobs.
The point of our project and point of interest was that we are both interested in fantasy football and wanted to see if there was a more efficient way to draft a team based on historical data. In saying this, we wanted to see if we could use the season data from 2021 in order to inform the decision of the players that you should draft. We were also interested in if there was any underlying factors that could affect a player's performance that did not necessarily have to do with how that player played the previous year.
So in our data sets, we had the three different data sets that were required. We had our first one, which was a CSV file that we found online. The CSV file contained every game played from 2019 to 22. It also included a ton of different statistics that weren't necessarily useful for us, like the Vegas spread of a game or the weather of a game necessarily wasn't really useful for us. So we had to use pandas and indexing and slicing to kind of cut down on the data and kind of clean it up and change it to a by position where all the columns were useful for us.
Then, in terms of our HTML dataset, we selected a HTML that uses a list of every player's performance and also their fantasy output. This will provide the insight to use about what players are more valuable than when drafting your team.
For our API, our third data set, it allows us to look at the defenses around the league. And because of this, we were able to once again use pandas and make a data frame that allowed us to show neatly each team's positional ranking. For example, like the Arizona Cardinals were ranked, I think, seventh against quarterbacks in the year 2020. And because by looking at the previous year's defensive metrics, this allowed us to kind of get a look at what the next year would hold potentially.
And then the insights we hope to find in our hypothesis is that from our selected datasets, we believe we can draw correlated conclusions across them. We hope to conclude that there's a holistic relationship between the datasets and can provide us with valuable insights. We believe we can utilize each respective dataset in order to create the best draft strategy possible using knowledge we acquired in this course.
So for our first data source, we have the CSV file, and what this code does, like these arrows right here, this one filters down by position. And what I did basically is we made a different data frame. So pass DF is quarterbacks, rush DF is receivers, catch DF is going to be rush DF is going to be running backs, catch DF is going to be wide receivers and tight ends. And so what this line does for these three is that it cuts it down to just that specific position, and then the game date 21, meaning it's a game in 2021, 01 and 02 are the months January and February. You don't want to include those because they're not part of the fantasy season. And then this results in making three DFs or data frames that all have relevant data to the specific positions.
And for our second data source, we found this data set online by searching for the best fantasy performers from the prior year. We used the BS4 module in order to web scrape the HTML. This function right here removes all irrelevant columns using regex. And then these functions also use regex, and this one uses regex in order to find all instances of touchdowns. This function removes players that did not score a single fantasy point the prior season, and this creates a column for the fantasy points relative to the best players by combining the fantasy points and the PPR for a player. This function also includes derived rating metric that will be discussed later in the insight section.
For our third data source, we have the API, and what this code does inside of this loop is that it basically takes every single team and appends their ranking and their points per game against a different position. As I said earlier, like it shows the Arizona Cardinals ranking against quarterbacks and how much points they gave up per game against the quarterbacks.
And then here's our resulting data frame for our CSV file. This is the QB data frame, and it only includes stats that are relevant to quarterbacks.
And then this is our HTML data frame. As you can see, we've got the fantasy points relative to the best player. As you can see, Josh Allen's the best player at the position, so he's got a 1 rating, and then Justin Herbert being the second one goes up. And then we also have the interception and fumble likelihood, which allowed us to derive this rating metric, which can rank the teams or the players based on tiers. Our third data frame is the defense one. As I said earlier, like it shows the Arizona Cardinals are ranked seventh against quarterbacks and their points per game against this position. So for our first insight, we have should the amount of games a player plays on different surfaces informing about draft decisions. So what this code does basically is it separates. It basically makes this data frame right here, which shows the average points per game per different positions and what the field surface they played on was, grass versus turf. As you can see, players tend to play better on grass, which then allows us to think if you're going to draft a player, you want to draft someone who plays on grass more often, aka they play on a home field made of grass. This insight is a player playing in indoor-outdoor stadium, indicative of performance. And what that basically shows is similar to the last one. However, this one has indoor outdoor, and the reason that these are two completely different data sets is because field of play does not include things that are underlying like weather. For example, in the indoor stadiums, like a dome, if it's raining outside, it doesn't affect the player's performance, and it never gets cold inside a dome because the temperature is regulated. However, in an outdoor stadium like the Pittsburgh Steelers stadium, it snows there and it rains all the time, and a player might play worse. Therefore, the average points per game in outdoor stadiums is lower. So this visualization, our first one, shows all four of these stacked up. The total length or the total height of each bar is the points per game by the average points per game by an offense. So it's the average quarterback, running back, and receivers points per fantasy points per game. As you can see, grass is the best compared to turf, and indoor is better than compared to outdoor. The different colors represent different position groups.
And our third insight was, can you use a derived rating metric to place players in respective tiers? Here's that rating metric I was talking about earlier. This is derived from the web scraping function and is calculated by position dependent on stats. For instance, a running back's rating is derived from their total yards per game and the likelihood that they will fumble. And then from that, the players were placed into respective tiers, and these tiers can be used as guidance for when you are drafting your team. The tiers are fine-tuned depending on the rating that a player got, as the weighting for each position differs, like I said. This is useful in that the tiers take more things into account than just last year's data, as they incorporate metrics that are indicative of a player's efficiency and performance. And then here was the resulting data frame. And then this is the visualization for that. It has each player tier going around, and then if you hover over something, you could see a player's rating value.
And then this is our fourth insight, which says, can the division that a player is in help you with your draft strategy? So what does basically is that the code goes through each division and it basically takes the rank. So for example, the AFC West is ranked 22.25 on average against quarterbacks. That being said, that means they're a pretty poor division against quarterbacks. So if you want to draft a QB, you would want to draft one that's in one of these divisions where the number is higher because the average defense is worse against that position.
And then for our fifth insight, we wanted to figure out if we could use the standard deviation of a player's fantasy points per game to reflect how consistent they are. We first started by dropping all irrelevant columns and then dropping the column that says unnamed, and then we grouped by player and total fantasy points, and then the standard deviation of that. And from that, it gives us this data frame, but it included non-values like you can see, so we had to make another one. And then continued, this is the visualization code. For every player that occurs in the CSV data file, it counts the amount of times they occur in a game, and it fills all non-values with 0. Then it goes into the for loop that will append this column next to the player, and then we can plot the standard deviation against games played, as you can see in our third visualization, with the quarterbacks along the right side. And this shows us how consistent a player is.
All right, so our concluding results and our final thoughts, some new modules that we had to use. Although we did go over in class, me nor Riley were actually good with regex until we had to use it during the project. And although we really found it challenging, we kind of pushed through it and we had to do it to find out what we wanted to get. And then we also had to use a Plotly graphing module because we had only used Matplotlib on the homework 6 that we used with the Taylor Swift data. So this allowed us to create a very unique pie chart that was very interactive.
In terms of new data manipulation techniques that we learned, we had never worked with data sets of this magnitude in class. This exemplified how powerful Python is as a data manipulation tool. This project also further expanded upon our skills using pandas and NumPy, web scraping, and APIs. We used methods of each module that we had never used before. And third, we learned that you can draw unexpected insights from data, even if you manipulate it the way you want to. And then for our greatest challenge was having to get creative with our insights that we gathered from the data sets. This was challenging in that there are only so many things that you can analyze regarding fantasy football. Despite this, we think that we discovered some very insightful findings. With that being said, it is challenging to apply the insights we derived about the players, as in fantasy football. You may not be able to draft the player you want because they might get taken. That is all.
Thank you.